Today we are going to solve another very interesting problem that is basically based on the real numbers, but the approach I am going to use is very innovative and very creative. So I just want to show you how exactly we can incorporate the beauty of geometry into the problem, which looks like a problem of real numbers. So let's start solving the problem. The problem says that x, y, z be the positive real numbers, satisfying the condition x square plus y square is equals to 49, y square plus z square plus y into z is equals to 36, and x square plus root 3 xz plus z square is equals to 25. It says that with these three conditions, we have to find the value of 2xy plus root 3yz plus zx. And once we get this value, we need to find or represent it in terms of p root q, where p and q are integers and q is not divisible by the square of any prime number. And finally, we have to find the p plus q. That's a beautiful question. You can just pause the video and try to find the value yourself. And if you're done with that, let's move ahead with the solution. After looking at the problem initially, you might think that using these three conditions, you should try to find the value of the variables x, y, and z. But that can be the one of the silliest idea that you can think of. Because finding x, y, z and then getting x into y, y into z, and z into x is going to be a Herculean job if you are doing that, right? So what I am going to do is, with this condition of x square plus y square is equals to 49, I'm going to think that this is possible with a right angle triangle. So if we have a right angle triangle, something like this, with x and y as the perpendicular and base of the triangle, we can say that the hypotenuse of this triangle can be considered as 7. So with this simple fact, we can say that x and y are the base and perpendicular of a right angle triangle with the hypotenuse 7. However, this condition cannot be linked geometrically by looking at the equation first. But what I am going to use here is, if I can write the equation y square plus z square plus yz is equals to 36, little differently, like y square plus z square, and keeping this 6 square in the left, minus 6 square is equals to minus y into z. And if I divide it by 2yz, what I am going to end up with is a cosine formula. So this is the very simple formula we have been knowing, and with this, the right hand side of the value is equals to minus 1 by 2, and we know cos minus 1 by 2 is possible when the angle is 120 degree. That clearly says that we can think a triangle with the side y, z, and the adjacent side 6. However, the angle contained as 120 degree. Fine. So far, so good. Now, for the third possibility, which says that x square plus root 3 xz plus z square is equals to 5 square, we can start building another relationship, which says that y square plus z square minus 6 square divided by 2yz is cos 120 degree. However, the third one is going to give us x square plus z square minus 5 square divided by 2xz is equals to minus root 3 by 2. That's actually cos of 150 degree. That clearly says that with the sides z and x However, the adjacent side is equals to 5 centimeter. We have the angle contained as 150 degree. Okay, so let me create this whole scenario in a beautiful geometrical figure. So we start thinking it. There is a side Z and side X which is containing the angle 150 degree as we have seen here. There is a side Y and X containing angle 90 degree as the first equation we have observed, and there is a side Z and Y containing angle 120 degree. However, the adjacent side is 6 centimeter. So we got the side length of the largest triangle present here, which is 5 centimeter, 6 centimeter and 7 centimeter. However, there is a point inside making an angle 150 degree, 120 degree and 90 degree altogether with the distances X, Y and Z. So far, so good. If we find the areas of these triangles, maybe the triangle ADB, it is going to be half Z into X sine 150 degree. So let me quickly write half Z into X sine 150 degree is the area. Similarly, area of the second triangle is half Y into Z sine 120 degree, and the third one is half X into Y. If I add these three areas and take the value respectively, I can say that this is 4 times the value. If I take the LCM accordingly, this is going to be 4 times 2xy root 3yz plus zx. Look at this, this is the Mamma Mia moment, okay? This is what we have been looking for, 2xy plus root 3yz plus zx. That clearly means the value we are interested in is nothing but this is the value we are looking at, okay? Fine. So it is 1/4 of the given value, okay? So the moment I start evaluating it again, this is what we are looking for, and this is the area of the triangle, largest triangle ABE. So let's find the area of largest triangle. As we know the three sides of the triangle, the area of the triangle can be obtained using the Heron's formula, and with that semi-perimeter of the triangle is 9, so the area of the triangle is going to be 6 root 6, okay? 6 root 6 is 1/4 of what is required. So if I get the value, it is going to be, the required answer is going to be 24 root 6. So finally, we can say that P plus Q is 24 plus 6, which makes it 30. And that's the awesome answer we are looking for. Hope you enjoyed watching and learning something very creative to solve the problem that looks like a real number problem but was actually the problem of geometry. How nicely I introduced the concepts of geometry in solving for the real number problems. And second very interesting point is that you should start linking the concepts all together. That's the real beauty of the mathematics. Hope you learned something very creative and very intuitive. To learn more mathematical ideas, like and subscribe the channel. See you in the next video.